Okay, so today we're going to look at pairs of angles on, I guess it was on Tuesday while I was out. You guys did the notes on angles. Today's lesson will not be on next week's test. Okay, so it'll be just on what we've done so far. So what we're doing today won't be until the next test. Okay, just want to make sure everybody was clear on that. What'll happen is we'll do today's lesson. You're taking a quiz. Tomorrow we will go over the homework and we'll go over the quiz as well, so that you can have those back. And then you'll get a review sheet that's due on Monday. Monday we'll go over the review sheet. Tuesday you'll take your test. Okay? All right, so pairs of angles. Before we actually talk about this, let's talk about lunch. So if you're sitting in the cafeteria and you are sitting here, and you have a friend sitting here and a friend sitting here, right beside you, you could say that they were sitting adjacent to you. If something is adjacent to something else, it's right beside it. Okay? As opposed to, does anyone know what it would be called if they're sitting over here? There's a couple of different ways you could say it. Anyone want to hazard a guess? Yeah, opposite is actually the best way to say it. They're your opposite. They're across the table from you. Okay? So, adjacent angles are angles with a common vertex and a common side, but no common interior points. We actually talked about this way back in 7th grade pre-algebra, and I can't remember if it was in the 7th grade book or in the 8th grade book, but all of you have been through that, I believe. So here's what it looks like. I've drawn some examples and some non-examples of adjacent angles. So here, angle RST and angle TSV are adjacent because, and I'm going to write that here, the common vertex, what's the vertex for both of those? Yeah, S is the vertex for both of those. What is the common side for both of these? But a side of an angle has to be a ray. Yeah, ray ST. Very good. And the business about no common interior points is this. If I shade in, you don't need to do this because it's going to make a mess. But if you shade in the interior of RST and you shade in the interior of TSV, that there's no overlap between those two. Okay? If you're adjacent to someone in the cafeteria, they're sitting beside you, not sitting in your lap. Okay? Now, that's different than RST and RSV. For angle RST and angle RSV, do they have a common vertex? Oh, don't everyone talk at once. Yes, what is the common vertex? S. Do they have a common side? Okay, Colton, tell me, do they have a common side? What are the two sides of angle RST, Colton? Hang on just a second. Sorry. Yes, and what are the two sides of angle RSV? Yes, and did you notice you said one of those twice, right? So the common side is ray SR. So why aren't these adjacent? Well, if I shade in the interior of RST and then I shade in the interior of RSV, do they overlap? Yes, Savannah's shaking her head yes. I appreciate the feedback. Man, it's really hard teaching over Zoom. I'd like it, if it could be one where everyone could have their mics open, but if it did, you would get terrible feedback. So we're not going to do that. All right. So in this diagram, we're going to pick up the pace a little bit. 1 and 2, pretty obviously adjacent. 2 and 3, pretty obviously adjacent. Angle 1 and angle 3, not so much. Why are 1 and 3 not adjacent? Do they have a common vertex? Yep. Do they have a common side? No, they do not have a common side. So if you go back to our cafeteria example, that would be like you're here and that person is here. They don't share a side. They're sharing this table, but not this side. Okay? All right. Moving on. Why do we talk about adjacent angles? So that we can talk about other angles. Really, the only reason to talk about adjacent angles is so that we can use them as a definition for something else. So, a linear pair of angles are two adjacent angles whose non-common sides are opposite rays. We didn't talk about this term in 7th grade, but we did do this idea that you have two angles that are right next to each other where this is a straight angle. Those are called a linear pair. You need to learn that term. Why? Because we're going to use it all year long. At the very end of the year, one of the last lessons of the year, we'll be looking at linear pairs still. And I will point it out to you when we get to it and say, see, I didn't lie to you. Okay? These are a linear pair of angles. They're adjacent because they share a side and a vertex and they don't overlap. And the reason they're called a linear pair is because it's two angles, a pair, that make a line. Together they make a line. All right, page 2. Complementary and supplementary angles. Again, this is something that we did in 7th grade math. So complementary angles are two angles whose measures have a sum of 90 degrees. Supplementary angles are two angles whose measures have a sum of 180 degrees. Okay, and I probably said it then, but it was 2 years ago, so let me repeat it now. Please don't say complementary angles are 90 and supplementary angles are 180. If you say that complementary angles are 90, that's like you're saying that they're right angles, and that's not true. And if you say supplementary angles are 180, you're saying that they're both straight angles, and that can't be true. So here, in this diagram, A and B are complementary. Why? Because 32 plus 58 is 90. Which two of the angles are supplementary? Is 32 plus 122 180? Try again. B and C, yeah. B and C are supplementary because 58 plus 122 is 180. All right, so that is the really basic part of complementary and supplementary, and you've done that before. What you haven't done before is this. You haven't talked about the complement of an angle. So the measure of the complement of an angle is 90 minus the measure of the angle. And the measure of the supplement of an angle is 180 minus the measure of the angle. So the complement is the piece that you need to add to your angle to get to 90 degrees. And the supplement of an angle is what you need to add to that to get 180 degrees. So we're going to do some problems here. Some of them are going to be more straightforward than others. The first one is really straightforward. The measure of the complement of a 68-degree angle. The complement, and I'll abbreviate it COMP, is equal to 90 minus 68. It's 22 degrees. Done. The next one, I guarantee you that there will be a question about this on a quiz and on the test, and that there'll be at least one or two people who miss it. What are you doing, Marion? So watch this one closely. So the supplement of the angle is 180 minus the measure of that angle. Because they gave you the measure of the angle in terms of x, our answer is also going to be in terms of x, which makes people skin crawl a little bit. They want to give a number. You can't give a number on this. There are two things that you don't know. You don't know the measure of the supplement, and you don't know x. So all I can do is simplify this side. This is going to be 180 minus 3x plus 17 when I distribute the negative. So it's 197 minus 3x degrees. That is the only answer that you can give for this. All right, now let's look at a word problem. This is another, yes, sir. I'm sorry, say, okay. So the supplement of an angle is 180 minus the measure of the angle. So they gave us the measure of the angle was 3x minus 17. So we just did 180 minus the measure of that angle. And then we just simplified this as much as we could by distributing the negative sign and then adding the like terms. Cool? All right. You're welcome. Yeah, anytime you have a question, stop us. All right. So let's look at this. An angle's measure is 3 less than twice the measure of its supplement. Boy, that's a lot of stuff. Find the measure of the supplement. I'm going to show you that there are two different ways to do this. Some people prefer one way, some people prefer the other. I actually look at the question to decide which way I'm going to work it. But here's what we have to be able to do on this. We have to be able to change this English sentence into a mathematical sentence. So the key word in English is the is. The is really means is equal to. In English, we typically drop the equal to, which would make it so much easier to understand. People would miss these things a lot less. So when you get to the is, that's the equal. So what comes before the is has to be written as some sort of mathematical expression. It says an angle's measure. Well, we could use any variable we want for that, but since it's an angle's measure, I use A. Is means equals. Then it says 3 degrees less than twice the measure of its supplement. Well, 3 degrees less means we're going to need to subtract 3 from something. What are we subtracting it from? Twice the supplement. So I'm going to do 2 times S, and make sure your S doesn't look like a 5 too much, less 3. So it's 3 less than twice the supplement. At this point, you have 2 choices. You can use the idea of the supplement of an angle that we did just a second ago, or you can write a second equation. I'm going to show you both, and it's going to be up to you to decide which one you want to do. So if you use the idea from above, we know that the supplement of an angle is 180 minus the measure of the angle. So you could do A equals 2 times the supplement is 180 minus the measure of the angle, minus 3. So A would be equal to 360 minus 2A minus 3. So grouping the like terms, we have A is equal to 357 minus 2A. So 2A is 357. Oh, sorry, 3A, my fault. So the angle is 119. Notice on that, though, they didn't ask for the angle, they asked for the supplement. Okay, well, I know that the supplement is going to be 180 minus the angle, so it's 180 minus 119 is 61 degrees. Typically, if a problem is asking for the measure of the angle, I do it this way. When they're asking for the supplement, though, I typically do it a different way. What I'll do is, I know that an angle added to its supplement is 180 degrees. So I'll write a second equation. An angle plus its supplement is 180 degrees. Then what I'll do is I'll fill in the angle with all of this from my first equation. So it'll be 2s minus 3 plus s is 180. Group the like terms, and we'll have 3s minus 3 is 180. So 3s is 183. So s is 61. I will leave it up to you to choose which way you want to do that. You can do it the 2 equation way, or you can do it the 1 equation way. Either is fine with me. Any questions about that, though? Okay. Then let's go on to the last page, which doesn't have very much on it, thankfully. So vertical angles. If I remember correctly, we studied these in 7th grade also. Vertical angles are 2 non-adjacent angles formed by intersecting lines. We could have also said that they are 2 opposite angles. Formed by 2 intersecting lines. So in this diagram, Angle 1 and angle 3 that are across from each other with that same vertex are vertical angles, and then angle 2 and angle 4 are vertical angles. We'll get into this a little bit more, but just as a reminder, what kind of angles are angle 2 and 3 here? There's actually two different terms you can give. Why are they supplementary? Right, and when we have that, there's a term for it. When we have a straight angle and then this ray going out that divides that into two pieces that we learned today, what was that term? We didn't do perpendicular today. They are supplementary, but there's another term. Yeah, they are adjacent, but there's another term. It's a linear pair. Yes, sir. I have 4 cats in my house. One of them is in the room with me at the moment, and someone shut the door, and so she wants out in the worst way. I'm going to let her out in just a second. All right. Well, that is it for today's lesson. Let me close that.